Welcome to Future Construct. I'm your host, Alex. So, let me ask you a question. What is the most expensive part of a modern, a 24/7 manufacturing plant? It's not the multi-million dollar robotic arms or the complex machinery. It's an empty floor.
That's exactly right, Alex. The moment production stops, the clock starts ticking on just catastrophic financial losses. And the number one cause of unscheduled downtime in a lot of these facilities is the failure of the very concrete they operate on.
It's a vulnerability hidden in plain sight. I mean, we see concrete as strong, but in the brutal environment of heavy industry with constant forklift traffic, chemical spills, and impact from dropped materials, a conventional concrete floor has a lifespan of maybe 10, 15 years.
Right.
And that's with constant patching along the way.
And, each one of those patches means a shutdown. The document we reviewed cited downtime costs anywhere from, $5,000 to over $50,000 an hour.
Wow.
So a simple floor repair can spiral into a multi-million-dollar event. So today, we're talking about a material that's really engineered to end that cycle. We're talking about industrial-grade Cercrete.
Okay, so Ben, let's break down its defenses. How does it stand up to just the sheer physical abuse of a place like a loading dock?
Well, it's built on the principle of superior hardness and toughness. ASTM testing shows it has up to 5 times the abrasion resistance of standard concrete.
5 times.
But it's more than just hard. Normal concrete is brittle. A sharp impact can cause it to spall and shatter. Cercrete has a much higher flexural strength. So it absorbs that impact energy. It's really the difference between, say, a ceramic tile and a steel plate.
And not defense extends to chemical warfare, too. I mean, the case study in that chemical processing plant was fascinating.
Yeah.
They had a floor exposed to sulfuric acid that was just eating through their specialized epoxy coatings every couple of years.
A constant and very expensive maintenance cycle. They installed a Cercrete overlay, and that was 7 years ago. Today, there's been zero maintenance and zero surface degradation.
Okay.
Its fundamental chemistry, which lacks those vulnerable calcium compounds of Portland cement, it's simply inert to that kind of attack.
But I think the feature that truly enables modern industry has to be the dimensional stability.
Right.
You can pour a warehouse floor the size of a football field with no joints?
It sounds impossible, but it's standard practice with this technology. See, shrinkage is what forces us to cut concrete into those small squares with control joints. And those joints are the floor's biggest weakness. They chip, they fill with debris, they disrupt operations.
Yeah.
For an automated warehouse that relies on robots, those joints are a navigational nightmare. A seamless Cercrete floor lets automated guided vehicles, AGVs, run completely flawlessly.
So you build a tougher floor that also makes your whole operation more efficient. But what about when that once-in-a-decade repair is needed? And this, Alex, is the most revolutionary part. This is the pit stop. A conventional repair is like taking a race car off the track and back to the garage for a week. With Cercrete's rapid set formulations,
Okay.
You do the repair during a planned overnight maintenance shift. It cures and is ready for heavy forklift traffic in just 90 minutes.
so a potential $1 million shutdown just becomes a routine zero downtime event.
Precisely. And this is why looking at the upfront material cost is such a flawed metric. Yes, it's a premium material, but when you can spend a little more to avoid a catastrophic production loss,
Right.
you're buying operational certainty.
And that certainty applies even in the most extreme corners of industry, right? Like a food processing plant or a flash freeze warehouse.
Exactly. In a cold storage facility cycling down to -10 degrees F every day, the thermal shock would cause normal concrete to just crack and disintegrate. We saw a case where a Cercrete floor has endured that for 6 years without a single crack.
Wow.
And on top of that, it's non-toxic and so dense it's easy to sanitize, which makes it perfect for food-grade environments. It's a solution that's engineered for the toughest jobs on Earth.
Now, here's a question we'd like you to think about. We've discussed how a superior floor enables the rise of robotics and automation in industry. As this technology becomes the new standard, what industry or process that is currently limited by the fragility of its environment do you think will be the next to be completely transformed by this new era of industrial resilience?